Thank you, Brian, I think. Let's make sure my machine is back awake. And we'll do a little... Hey, there we go. So, yes, good morning, everyone. So we're going to have to work on that. My name's Jay Schmelzer, and as Brian said, I'm a director of program management at Microsoft, which means you have no idea what it is I actually do, and that's okay because my parents don't know either. So, but yes, I do have the privilege of leading the team responsible for .NET, the runtime framework, programming languages, kind of core developer experiences associated with that. What I thought we'd do for the time we have this morning is spend a little time and talk about what trends we're seeing in the software development industry, what's motivating and guiding the direction that we're taking with both Visual Studio and .NET, and then dive into some specifics about how some of those things will manifest themselves in the way we're building the products and the kind of capabilities that we're making available. Be kind of a quick, sort of whirlwind kind of tour of things. Hopefully it'll give you enough visibility into what's going on that you can help figure out where you want to spend the rest of your time here this week and dive a little bit deeper. I will say I do have one very simple ground rule. If you see something you like or you think is cool, it is completely acceptable to clap, cheer, applaud. I don't get offended. That's great. If you see something you don't like, we can talk about it afterwards. With that, let's go ahead and jump in. First, I think it's important to think a little bit about and understand what the key themes are we have when we're designing Visual Studio and we're designing .NET. I think it helps give you a sense of the direction we're going and a basis to have conversations and to interact and give us feedback about where we are or aren't hitting the mark for the kinds of things you need. So for the last about year and probably for the next at least 18 months or so, there are really three key things that are driving the team. The first is ensuring that we're creating an application platform and set of tools that enable you to continue to maintain and evolve the existing systems, the existing applications that you've built on .NET. I know we tend to spend a lot of time talking about what's new, what's coming, all these different things, and we don't spend nearly as much talking about how we're continuing to invest in the places you've invested with us. Right? We know you have applications that run your businesses today built on .NET, and we know that you need to keep managing those, we need to keep evolving those going forward. So that's a key aspect when we think about the innovation cycle for .NET, is ensuring we're thinking about where your current investments are. The next thing we've been doing, and this is something that's been happening across Microsoft as a company, is really changing the way in which we work and being, to be quite honest, more modern and having practices that are more in line with the way other software products are being built, other application platforms and languages are being built, as being completely open and transparent with the way we're doing that development. So this openness isn't just about open source, it isn't just about putting code into a public repo and making it easier for people to look at it and actually ideally contribute to it. It's actually about being open in how we're doing the work and how we're doing the design, having a conversation, getting feedback, iterating together as a community from the beginning. Now, I'll talk a little bit more about sort of the progress we've made here towards the end of the time this morning, but it's been a really interesting journey. There's some things we've gotten right, some things we've gotten wrong, and some areas that we're still a ways from actually doing well. The last part, and now this is probably one of my biggest challenges as kind of one of the people leading the .NET team, is changing the perception and changing the mentality about what .NET is all about. Typically, if I was to ask you, what's the first thing that comes to mind when I say .NET, one of two things is going to come to mind, either Windows or Visual Studio, right? Like .NET is just known as a great platform for building applications for Windows within Visual Studio. That's not all you're being asked to do anymore. You're being asked to build applications that run on all kinds of different devices, that run on different operating systems. And we want to make sure that your investment in learning and understanding .NET, learning and understanding our programming languages, carries forward into those new demands, into those new application types. So the kind of short way we say this to the team is, .NET is no longer just about Windows. It's about any developer building any application targeting any device or operating system. That's the direction we want to head, and that's what we want to do. And it's all about ensuring that you're carrying your skills forward. So that's a little bit of what I want to show you, when we get into the details of the things today. Show some basic investments, some basic ideas, just to give you a sense of where we're doing the investments there. But to start, I thought it was interesting to kind of play a quick video that showcases an example where a customer is using and taking advantage of a lot of these new capabilities and how they're being able to extend the reach of their .NET skill set beyond and into the current demands.
National Instruments serves over 30,000 unique customers on this planet. We have a need for very large, high-powered engineering productivity software. At the same time, we need to have the nimbleness to deliver multiple quick applications to market on mobile platforms in a cost-effective way.
With the tablet experience, we really wanted to create a simplified subset of the desktop experience aimed at engaging kids as a stepping stone to getting them on the Mindstorms platform.
The fundamental benefit in being able to use the same code base for industrial and consumer apps is productivity and cost. Once we saw aspects of .NET were open and there was an ecosystem of suppliers like Xamarin, we were confident that we could use Visual Studio as the primary development environment to reach those targets that we wanted.
We were able to get the performance that we were looking for across a multitude of devices. The appearance and the look and feel of the app was another important area for us. We really wanted the app to be integrated into the device and to look as native as possible. And with Visual Studio and .NET, we were able to accomplish that.
We have both an extremely productive development environment, a world-class tool and language, and the portability to the platforms that we need.
I could have my Android device and my iPad hooked up to the computer. I could be targeting both of them, compiling them, running them on the device, and I don't have to switch between tools. I didn't have to learn Objective-C. I didn't have to learn or refresh myself in Java for Android. I was able to leverage off of my knowledge of C#.
Every developer on our team may not even have the ability to build locally for all the mobile platforms and all the platforms that we deliver for on their machine. Team Foundation Server allows them to queue those builds to farms that are pre-configured to be able to do the correct builds, and it does them in parallel very quickly. The feedback from the development team has been incredible.
If I can write one piece of code and it works everywhere, that makes me very happy.
The tool we provide is used by people throughout the world to just do amazing things. They've made laser eye surgery devices, the CERN Hadron Collider, Lego robots, and seeing the delight in the way that the world is truly better through science and engineering because of the tool that I get to work on is an absolute delight.
I think probably my favorite line in there is, I get to write one piece of code and it runs everywhere, and that makes me happy. That makes me pretty happy too. So let's start diving into some detail. About a year ago, we introduced the notion of .NET 2015. And I admit it's probably been a little bit confusing what that is all about. And really, so I want to spend a few minutes and we'll kind of try to break it apart a bit. When we talk about .NET 2015, there's really two kind of core interactions, core experiences with the .NET framework that we're actually talking about under that one umbrella. The first is .NET Framework 4.6. That's the latest version of the .NET framework that we all know and love, that we've built all of our applications on. That is I typically call it the full framework. It's the complete set of libraries and things you need to build applications, whether you're targeting a Windows desktop or even a phone, or all the way up into a large-scale, high-end web service or set of services. It's a complete package. It versions together as a package. We release it as a package. And then over time, we've started being able to add and pull things apart to where we have some libraries that you can get independently and version independently, but the core of it is a single package. That will continue to be the way we work in that model, and it'll continue to be a place that we invest. And we'll talk about some of those investments in a minute. The thing we introduced last year was this notion of a .NET Core. And what .NET Core is a reimagining, a re-envisioning of the .NET runtime and framework with the modern application needs and modern application design patterns in mind. If you think about when we started creating the .NET framework, and I wasn't on the team at the time, but I was definitely a user of it in the early days, the primary design patterns were client-server applications or 3-tier applications. They were very, web-based applications in that model. Today, we have things like microservices. We have, IoT. We have phones. We have all kinds of different form factors with completely different demands on the applications that run on them and the way we manage them. And we needed to take this opportunity to kind of go back in and revisit the approach we were taking to .NET to better meet the demands of those types of applications. So that's kind of the frame we're going to use over the next 45 minutes or so that we have, and we'll dig into all the pieces. So of course, while we have these two libraries, and I will talk about how we design them with the intent of keeping them as consistent as possible across, but they are different implementations. We also have a core set of investments that span both framework kind of experiences. And these are things like the runtimes, the JIT compilers, the actual managed compilers, so the VB and C# compilers, as well as a set of packages that are available in an on-demand manner. They're not part of the core full framework package. That was two words I should not ever use together, right? So not part of the full framework package. They're NuGet packages that can be brought in and applied to either .NET Core or the full .NET framework. Driving the designs of these are a set of application types, or a set of, we typically at Microsoft call them workloads. But essentially you have things like our desktop UI stacks, WPF and Windows Forms, ASP.NET, a web stack that has really two flavors. I'll dive into detail about ASP.NET 5, but one that targets the full framework and one that actually is available to run on both. And then universal Windows applications that are actually running on the .NET Core kind of framework set and library set for targeting the universal Windows platform of devices. So using this frame, let's dive into some details of each of these. First, we talk about, in the common layer, I mentioned these are investments around a runtime and around ensuring that we're essentially making your application better. In a lot of cases, especially in the case of the runtime and the JIT, these are things that for the most part, you won't really see as a developer interact with, or you shouldn't if we do things right. You just get the benefit of your application got faster, or got more reliable, or more secure. Now, in the case of the JIT compiler, we may have had a little bit of a stumble there, and you may have seen a few more issues than you should have, and realized there was a new compiler there, but we're working through those. But this is what allows us to improve the efficiency and the performance of your applications. In the general compiler space, one of the things that naturally we did was continue to evolve the C# and VB.NET languages. Now, in this release, we didn't introduce a kind of a paradigm-shifting language capability like async or link or even generics that we have in the past. What this release was really about just addressing those annoyances or the things that just aren't as efficient as they could be when you're just doing your everyday programming. So looking at small things that round out that general experience with the languages and make you just more productive. Let the compiler do more work for you for common tasks, common patterns that you may be implementing. And of course, part of that also is ensuring that we're rounding out the developer experience and taking, making sure that Visual Studio and Visual Studio's world-class debugger has the ability to work with all the capabilities of the languages. In the past, we'd introduced a new language capability, but then we gave you no mechanism in the debugger to actually interact with it and work with it, which kind of hamstrings you a bit and doesn't make it as a productive experience as you'd want. And of course, continuing to invest in F# and Visual F# so that we have a function-first programming language available to you on the .NET platform. This is just something that we think about as a part of the portfolio so that where you have application needs that benefit from functional programming kinds of techniques, you have a language available to you on .NET to reach for and interact with and use for those purposes, but also really nicely interact with your C# or VB.NET code. One of the aspects at the core, too, that was a big investment for us that we've been spending some time on that we're just beginning to see the return on is the ROSLYN project, or officially the .NET compiler platform. As Brian said, we can do a good job of taking something short and making it long when we name it. What this is really all about was a re-envisioning of a compiler and the interactions you can have with a compiler. Compilers have just intimate knowledge of what your application is trying to do. It knows what you're trying to accomplish. But it historically has been a black box. You can't get access to it. You can't get access to that richness of information. So people that are trying to create tools, people that are trying to create analysis tools and so forth, had to re-implement their own parsing logic. They had to try to match the parsing logic of the language. They had to be bug for bug compatible with the compilers and so forth. And they still had a hard time getting to that next level of understanding, the semantic understanding of what your application was doing. With the Rosslyn project, we wanted to change that. We wanted to turn that black box into something that was more transparent. We wanted to create a set of APIs that exposed that intimate knowledge the VB and C# compilers have of your application to tool vendors, to people building experiences around the languages. So this really kind of manifests itself in probably three main areas. One is just richer and deeper tooling, better refactoring, better code navigation. Those kinds of things are just a lot easier to do. The next is a next level of code analysis. So going beyond just static code analysis and getting into semantic understanding of what your application is trying to do. Next level understanding of application patterns and so forth. And good and bad rules. And then creating experiences that allow the authors of these tools to create better experiences for getting started with them. If you've ever tried to apply a code analysis tool to a mature code base, what's your experience? Typically, you get hit with this wall of errors, right? Like thousands of these errors. So what does any normal developer do? Uninstall the tool. Right? I don't want to deal with that. Well, what we've done, some of the capabilities we do through Rosslyn is we make a set of APIs available that allow you to kind of forgive your sins and start fresh. So you can kind of take down the wall, ensure you're being clean going forward, and then as you have time or as you're getting into an area of a code base and reworking it, start chipping away at those errors. So you're getting the benefit of the tool going forward without having to spend months to kind of going through and cleaning up all that backlog. That's just one example of something. The other place that we're seeing this used a lot is in extending the library experience. So when you grab a library, we grab a chunk of code from NuGet or something like that, allowing the author of the library to create a rich experience inside of the developer experience to help you understand how to use that library in the right way. As a library designer, we always want to ensure that we're creating our APIs so they're very easy to understand and can be consumed without reading a bunch of documentation and so forth. But inevitably, there's always somewhere where there's a pattern that emerges of usage that you're like, ooh, that's really not the way we intended to be used, or there's a more efficient way of using this. Or maybe there's a new API that we implemented that's better than the old ones, and we want you to be aware of it. Well, using ROSLYN extensions, you can have the development experience actually teach the developer the best uses of the API. Another great example I've seen of this in mid to large-sized development shops is to create an experience where the IDE helps you enforce your coding standards. As a consultant, I can definitely remember going into many of my clients, and one of the first things that happened when we showed up with the project team was we were handed the coding guidelines paper, right? Some of them were pretty big. Of course, as consultants, we memorized it and followed it to the letter. But man, wouldn't it be nice if you could actually have Visual Studio help you, as you're writing code, understand when you strayed from one of those coding standards, rather than waiting for a code review or someone to check it and have to go back and change it. Well, those are the kinds of things you can do with ROSLYN extensions and ROSLYN analyzers. Of course, the other big area of investment is really looking at package management. How do we move from an experience that's thinking all about assemblies and specific DLLs that you reference and understanding the hierarchies and dependency trees to packages of capability and having a package manager that can go through and resolve all those things for you and ensure you've got the right set of dependencies for your application. In the web space, also looking at extending this beyond just packages, .NET packages, but the common packages and package managers you need in a web environment like Bower and NPM, and extending those, extending the Visual Studio experience to be aware of JavaScript packages and JavaScript package managers as well. Okay, let's take a look at kind of an example of one of these ROSLYN extensions that I was talking about. So if I switch over here, what I've got here is a very simple Windows Forms application. It doesn't do it doesn't matter what it does. What's important here is if I look at this, you'll see that I have no errors, no warnings. This code is good. There's nothing wrong with this code. I can go through and you see that, we're throwing an exception. If something's if something's null. We've got a little data type class here that's just kind of a person with a name and an age, assigns the values as part of the constructor, adds a year, returns kind of a formatted string. So one of the things we did to sort of demonstrate the capabilities of the Rosslyn stuff was that we went in and we created an analyzer that would teach you about opportunities to take advantage of new capabilities in the C# language. So if I go into the extensions, you see I have this C# extensions package. It's available on GitHub. The code's all there too, so you can see it and use it to learn how to build one of these. And if I can just enable this. Now, that's going to cause Visual Studio to restart. So we're going to switch over here to this other instance where I've already enabled it. So if we go into the tools here, we should see that it's actually enabled in this instance of Visual Studio. Now, if I scroll down, you'll see that suddenly I'm starting to get some squiggles. I've got a squiggle here over sender. If I hover over this, or put my cursor there, go over here, you see we get the light bulb. And one of the things that the light bulb is saying, hey, you could take advantage of the new name of keyword in C#. So rather than passing in the string, you just you call name of, and we will always resolve it to the name of the value. So if you change the variable name, change the parameter name, name of will keep it consistent as opposed to knowing, oh, if I changed it from sender to something else, I would have to go in and catch the string. So it's giving you a preview right there in the editor. If I just click it, it'll apply that change for me. And now we see name of has been applied. If we go over here and look at the person class, you may have noticed it's hard to see a little bit, but you see that the color here is different between the name and the age. Again, if we go in here, look at the fix, we see that here's an example where it's saying, hey, you could use the new getter only auto property because we're not assigning a value to the name outside of the constructor. So we don't need the ability to have a setter on the property. We can do a getter only property. Again, let's go ahead and apply that fix. The last one we'll look at is we'll go down here to where we're formatting our string. And here's a case where we can see that what it's suggesting is that we could go from using string.format to an interpolated string, a new capability of the language that was introduced in 2015. If I apply this, you see that we now have a much more readable formatted string. We're no longer doing those parameter matching between the placeholders in the string and the values. So a couple things to show. One, couple little C# features that are new, and you see the idea that they're just rounding out the experience. None of these are earth-shattering, right? We didn't, change the world necessarily with the capabilities here, but we just smoothed out your experience. And the other is how you can use something like a ROSLYN extension to have an interactive experience for learning new capabilities, learning new things, and teaching better usages. And of course, ROSLYN extensions can be used interactively in Visual Studio. They can also be used as part of a build process, so you can flag things as part of a CI build and so forth. Okay, just a couple examples there of things that you can do. And again, that's all available out on GitHub, so you can get the extension, you can get that extension, you can get the code, and use it to learn to build your own extensions. Okay, let's talk a little bit about the full framework in 4.6. So I mentioned 4.6 is the next version of the .NET framework. Areas of investment here, you can really think of it as this is that space where it's all about ensuring that your existing investments in .NET, your existing applications, continue to get better and continue to be able to be modernized or evolved into the direction that you need to for that code base. So it's things about ensuring it's highly compatible, performance, modern hardware, and so forth. Let me talk about compatibility just for a minute, because it's one that comes up a lot when I talk to people. So the 4.x family of the framework is all a set of in-place updates. We don't do side-by-side updates with the full framework anymore. So that means we have a high compatibility bar and a promise that we are being highly compatible. As Brian mentioned, I've been at Microsoft for a little over 12 years. Now, of course, we all have the same situation, but of course, when it comes to Microsoft, I am the Microsoft tech support for my entire extended family, right? Doesn't matter what product they're using. If it's got Microsoft in the name, I'm getting the phone call. I probably went 10.5 years where the interaction was something along the lines of, okay, Dad, yep, understand, try this, no, okay, yeah, you may have run into a problem. let me follow up with the team that is responsible for that product, and I will help you figure that out, right? Probably about a year and a half, 2 years ago, I get a call from my dad. It's like, hey, Jay, I'm sure this isn't your stuff, and you probably don't know what the real detail is here, but I'm trying to install the latest version of TurboTax, and I got this .NET framework fails to install error. I'm like, great, broke my dad. There are over 1.7 billion machines actively taking updates of the .NET framework from Windows Update alone. That is a massive number of machines, and that's only the ones from the public Windows Update server. Anybody managing machines behind a corporate firewall using other update mechanisms, that we don't have visibility of those, we don't see those. So that's a huge burden, and that's a huge responsibility that we have, and we take that very seriously. We have a set of tools. We've been investing a lot in ensuring that we have, big app compat labs, that we have tools available for you to run over your existing projects and code to understand where we've had to make a behavior change in an API. We have quirking modes inside of the framework, so when you run a .NET 4.5 application, an application compiled to target .NET 4.5 on .NET 4.5.2, .NET 4.6, anywhere where we had a behavior change in an API, we will give you the old behavior. We will give you the 4.5 behavior, or the 4.5.1, or 4.2, whatever you targeted. There are a few exceptions to that. If we found a case where there's a security fix we had to make that just wasn't possible to do in that mode, or it didn't make sense, you would rather be secure than compatible, those kind of things. But that's what these tools help you understand. Anyway, that's just a brief understanding of kind of how we think about it. If we go into some of the areas where we invest in that space, WPF is a great example. Amazing UI technology for building rich desktop experiences. Investments here around the fundamentals, performance. Your apps get faster. Interoperability with DirectX, but also really modern hardware. So ensuring that as you're running your applications or developing applications on machines that now have touch and things like that, you have a great experience for providing a touch interaction with your application using WPF. A big investment in this area has been around tooling as well. So bringing a lot of the tools we've done for building Windows Universal or Universal Windows applications, performance tools, code UI navigation tools, debugging tools forward to support WPF as well, because they're all just XAML-based approaches. The other is Windows Forms. Yes, we still have engineers that work on Windows Forms. Windows Forms is an amazing UI technology. Probably, I get in trouble saying this too often, but one of the most complete technologies we've ever created. It's got a great design time, a great runtime, and an amazing ecosystem of partners and components that build around it. It's good, and we continue to invest in it. Here, again, it's much more about fundamentals, performance, reliability, security. We also think about what was this technology designed to do. When Windows Forms was being designed and developed initially, touch didn't really exist. Phones didn't really exist. We're not going to go back and try to retrofit Windows Forms with those kinds of experiences. It just doesn't make sense. At the same time, we certainly didn't have a design principle that said, as hardware gets better and displays get better, Windows Forms apps should start looking bad. Right? That was not the intent. Right? So high DPI is a thing that we're going to go address. We're going to look at ways to address it in the core so your applications continue to look good. You have the ability to continue to use Windows Forms as a technology with more advanced hardware and so forth. That's just how we think about it. Hopefully that gives you a little insight into what's going on there. So again, let's switch over and take a look at some examples of a few areas of investment, and we'll focus on kind of the core developer debug experience in WPF. So in this case, I'm going to run a little application. You may have seen this before. It's a WPF application. It goes out and calls a web service. Let's just run it real quick so you can see what it does. And you can imagine this is just an app that maybe is used in the back end of a car service or something like that, where we can see the cars, the drivers, their ratings, and so forth. So let me go back in and refresh this data again. And as I go and run this, and we step, one of the things you'll notice, there's a little tip that showed up here. 358 milliseconds elapsed. One of the things we notice when you go try to understand a performance problem, the first thing you tend to do is fire it up in the debugger and just start stepping around and see what happened. Then you see something that took a while, and you go look at it again. And depending on what it was, you either stopwatched it or you started writing debug statements in here, right, to try to figure out how long things took. So we said, why would you need to do that? Why don't we just show you how long the last chunk of code took to execute right within the debugger? So that's what you see. So every time we step or hit a breakpoint, really is what's happening here. When we hit a breakpoint, the debugger is just going to go and tell us how long the last chunk of code that executed took to execute. Yeah, I was going to say, don't make me remind you of the ground rule, because people usually clap for that. No. The thing that's also nice about this is it's a link. So if I zoom back out here and I click on it, it's going to take us right into the diagnostic tools and give us visibility into what's going on at that point. And we can move around, we can see processor usage, memory, network, whatever we've got configured to be collected is all available to us. So we're allowing us to dive in and start seeing where our problems are in our code. So that's cool. Just making us more productive, that's always good. But what about actually understanding and kind of exploring the data that we have here? Right? So we've always been able to come into the immediate window and do something like this, right? Print the vehicles. Say, okay, we got 19 or so vehicles back. What if we want to start playing with the data and see, maybe there's a query that we want to be issuing here instead rather than just pulling everything back. Maybe we want to limit this a little bit. Well, we can play around with the richness of that stuff, and we can say, okay, let's just go in here and say vehicles.where. Let's do rating ID, rating average. And now we've issued a link query or written a Lambda right in the immediate window to start exploring that data. Thank you. We could also go and do something like this. So maybe, just seeing that it's a vehicle isn't really going to help us. Maybe we want to actually see a few values, specific values of the data coming back. So now we can go and we can have a new anonymous type that just gives us visibility into what that set is. Now, of course, we can also use this in the watch windows and locals and all those kinds of things. So we can write our lambdas and our link queries and then kind of pin these values into the other debugger windows and explore them that way and so forth. When you hover tips, all those things kind of work in a nice integrated model. And of course, once we've played with this and used that experience to kind of figure out what we wanted to change, we can now go back into the code and just sort of kind of change the way that our query works here. So say, come on, no, we really can. Really? Why my machine has gotten finicky, I don't know. It's supposed to be still running. Let's stop real quick. There we go. .where. Come on, you can do this. No, really. Unless, of course, you have a syntax error, which I probably do. Warnings go away. Let's just go away. Oh. What did I do? Oh, yep. Thank you. There we go. Problem between keyboard and... Yeah, man, that's such a cool demo, and I killed it. So what you saw was someone fumbling around with code. Actually, no, I didn't kill it. What you saw was someone fumbling around with code in the debugger and being able to get it right while everything's working, right? So you don't have to be perfect the first time. How about that first? No? So again, it's all about extending that experience, extending the richness of the debugger, extending that world-class experience so you can use and take advantage of everything that you could write, you can do in the immediate window, get the code the way you want it, apply it back in without having to stop and restart the application. So that's a little bit of coding, but what about the visual aspect of this application? WPF is extremely powerful, but you can also get to extremely complex and deep and hard to understand and navigate visual trees, right? Well, what if we sort of borrowed a trick from the web tooling that we've been working on, and we introduce a way to put this visual tree, we have a visual tree that shows you what all the elements are, so we could navigate with that, but we can also go into selection mode, where now, as I move around the application, and I hover over things, and I select them, we now use the running application to select the visual element that we're interested in working with, right? So we can just point to where we care about it on the application, and that syncs right with our visual elements that have been generated. We can go over here into a live property grid as well, and we can play with those values. So if I decide that maybe the font size needs to be bigger, make it 35 and switch back, you'll see that the phone number got significantly bigger right in the running application. And the application's still working, so I can go and continue navigating through and ensure that the changes I'm making are going to work with my actual data as I'm going through, and not have to stop, rebuild, start all over again. We can just do it as we're playing and experimenting and iterating, and then apply the changes that I care about back into the application. Just an example of some kind of interesting ways to allow the developer, oops, let's get out of selection mode, to allow the application to be kind of the design surface for itself and help us interact with and be more productive working across these rich visual applications. All right, that one clearly wasn't exciting to you guys. Of course, another area of investment for us in this recent product cycle has been supporting Universal Windows and the Universal Windows platform. If you're not familiar with this, it's essentially introduced as part of the Windows 10 family. It's a consistent API surface across the family of Windows devices, from small devices like IoT devices, HoloLens, phones, up to large wall-mounted things like Surface Hub or big Xbox experiences, where you can have a consistent set of APIs and the opportunity to build an application, build an assembly, build a DLL that can be copied and executed across any of these environments. Also gives you a set of experiences for dynamically changing the behavior of the application, some UI controls that know how to resize themselves and relay out themselves based on what's available, and so forth. I think one of the more interesting aspects, personally, of this is the fact that it's the notion of a single application identity. So even if you don't want to package everything into one app, you don't want to carry all the assets for the Surface Hub wall mount display down to the phone, you want to have different packaging for it, you can still have a consistent identity across those application packages so that when a customer acquires an application on one Windows device and log into another device, they have the application available to them, tailored to that device. This is really what we mean when we talk about mobile first. It's about this mobility of an experience, the ability to have an application experience that you develop for your customers that works across the different devices that they interact with over the course of their day. We don't all work on one device all day long. We tend to move between phones and tablets and PC-type devices. And having the ability to create one experience that can move across these and be tailored based on what they're trying to do. I don't want to do the same thing on my phone that I do when I'm on my PC, but there are a set of tasks that I probably do want to be able to just quickly do when it's just my phone that I have available to me. That's really what we mean by this. That's what the opportunity is. As part of this, one of the things that we introduced was the concept of .NET Native. So .NET Native is an extension of the compiler toolchain for .NET developers. So rather than stopping with the output of the C# or VB compiler, which is the intermediate language, the IL, we connect in the back end of the C++ compiler. So now we take it all the way through to a native image at the end of the compilation process. Same back-end compiler you would use if you created a C++ application in Visual Studio, so it's the same highly optimized output for your applications. The result? All the productivity of .NET with the performance of C++. We statically link in what you need, so you carry with you the versions of the libraries that you built with. Someone else can deploy an application with a different version of those libraries. It doesn't affect you because they're statically compiled for themselves as well. Improved startup time, sometimes dramatically for applications because we're not, enginning and doing that final compilation on startup. Smaller memory footprint for each app because we only bring in what you used. We don't load up the full framework just to get your app running. Pretty much any experience you have with managed code is still available in this environment as well. You can still do reflection. You can still do those kinds of things. You just have to, in some cases, give us hints of what metadata you need us to carry around at runtime so that you can do that reflection that you wanted to do. Most times, you don't even have to worry about it. We understand the most common app patterns, the most common reflection patterns. We can detect them. We pull in the things you need. But worst case, there's always a fallback, and you just tell us what metadata you want, and we'll carry it with you. We've introduced this for the universal Windows applications. That's the beginning of this technology. You can imagine we will apply it other places as we get that scenario finished. But I think it's an exciting starting point for where .NET can go. Yeah, we kind of already talked about this. So that's the Windows kind of family of devices. What about other devices? Well, you need to be able to build apps as a .NET developer for iOS and Android. And to enable that, we've got this great partnership with the folks at Xamarin. And so Xamarin allows you to take those .NET skills and build native iOS and Android applications using .NET, but accessing 100% of the APIs of the iOS or Android environments you're targeting. The thing that's neat here is that not only are you able to do this as a .NET developer, but because you're using .NET, you're able to share, in many cases, pretty significant amounts of code across all those implementations. So you don't have to do, your Android app in Java and then redo your app for iOS in Swift or whatever you want to write it in and so forth. You can share a lot of that logic as C# code across all those implementations. Talking to folks that use this technology, we see upwards of 80% code reuse across these different application instances. Because if you think about it, everything, business logic, view models, data models, all those things are the same no matter what OS you're targeting or what app type what platform you're targeting. It's just the views that actually get specific to iOS or Android or Windows. Recently, they've introduced a set of tooling around the UI as well, so you can have visual designers to design out your UI. They've also introduced Xamarin Forms, which is a technology that allows you to actually extend that reuse even further into the UI and have a single UI package or single technology that spans the different UI stacks. Again, it's that kind of technology. Xamarin Forms isn't going to be perfect for every type of application or every aspect of your application. But you can imagine, just like any desktop application or web application you've built, there's the part of the app that really matters, the part where the customer is in there all day long and that's what they're working with. And then there's stuff that just has to be there because they need to change code tables or they need to log in or those things like that. But having the ability to implement that shared common UI once and have it consistent across everything is a great productivity win. And then drive in with the 100% native API for the stuff that really matters. So that's the device side of things. Let's talk about the server. ASP.NET, amazing framework for building web-based solutions, websites, web apps, web APIs, and so forth. But it too was getting to the point where we needed to go and think about how do we best design this technology so that it works in the new modern app types, modern app patterns that you're targeting. Specifically in this case, thinking about microservices. Also thinking about the kind of execution environments that ASP.NET and web-based applications are being deployed into, specifically thinking about things like the cloud. So working inside Cloud and Enterprise, I have counterparts that are very interested in density and how much can we get onto a server. Turns out, any of you working in private environments deploying to servers on-prem, you care about that too. How many apps can I reliably run on my hardware efficiently? So thinking about how can we go design ASP.NET in a way that allows you to get higher density, maintain great performance, be more modular, allowing you to pull in just what you needed, and be able to do things like have confidence that the version of the runtime and frameworks you built your application with, you tested it with, and you deployed with, are the same versions that continue to be there as new applications come into the environments that maybe took advantage of newer runtimes or newer frameworks. So we provide a complete application-level isolation of the .NET runtime and framework libraries at the app level, if that's what you want to do. So really kind of increasing your productivity there. This is also where we are investing in taking this implementation and ensuring it's available not only for Windows, but also for Linux and Mac OS. So now you can go and build applications using ASP.NET and deploy them to a Linux environment. You can build an ASP.NET application and run it and debug it locally on a Mac, And kind of really, in two respects there. One, extending the reach of your existing .NET, ASP.NET skill sets, but also opening up ASP.NET and .NET to a new set of developers that don't use Visual Studio or don't run Windows today, and making the technology more approachable for them as well. So let's take a look at a couple examples of how this kind of manifests itself. So over here in Visual Studio, I've created a new ASP.NET 5 project. This is just kind of file new ASP.NET project. A couple things you'll notice. This is a place where we went and took the move from assemblies to packages concept, right? So our references are no longer specific assemblies, they're packages. And packages contain packages and so forth. That eventually, you could drill down and you get all the way into, specific assemblies in some cases, at the very bottom of everything. New project system here that's been modified and updated, so everything now runs off of much more straightforward files. In this case, just little JSON files. So here you see project.json that just describes the package dependencies I have in my project. If I go through and decide that there's things I don't want, so maybe I don't need, the Google authentication, save that. If I switch back up over here, you'll see that the Google auth is now gone. Come back. Oops. Control Z over here. Save it again. You'll see it's going to get updated, and it's going to show back up in my project references there. Another thing I'll show that we did here is, let's just go and start this without debugging. So essentially, Control F5 it, and we'll bring up our application. Yeah. And no, our application isn't the Azure portal. Come on. Why are you slow? Let's try that again. Start with the debugging. Interesting. Oh, because the browser hung. One last time. Launch, there we go. So here we have our, our simple page. We can click around and so forth. But let me do something here. We'll go over into the controllers. We'll go into the home controller. And this is where the message is coming. You see we've got some C# code. If I just change this, say your awesome application description, save it, go back over here and just refresh, what we should see is that change will get picked up without me having to stop and restart and rebuild. This is because by default in the developer mode, ASP.NET 5 is using Rosslyn. It's doing in-memory compilation of your C# code. So it's just looking for changes to any C# or Razor code that you have and automatically recompiling that chunk in memory and serving it back out. So you don't have to go back and come back into a complex application. You just make the changes you need to and give you a more iterative experience there. So something, cool. Turns out it also makes it a little faster because we're not writing an assembly to disk every time you go and kind of Control F5. But what I really wanted to do here was show you how, because now we're cross-platform with ASP.NET 5, what I can do is I can build my ASP.NET application like I would today on Windows using Visual Studio, but then deploy it to another environment. So in this case, we'll deploy it to a Docker container running Ubuntu Linux. In my case, I'm going to do it in Azure. So we're going to go out and we're going to query Azure for the list of virtual machines that I have, which unfortunately is kind of a big list. There we go. We'll choose our Docker host demo. Say OK. And we're just going to go ahead straightforward and publish it. Now what Visual Studio is going to do, it's going to issue a set of commands and package up that application. So if we go over here and we'll see that we're going off and packaging up the application. We're going to go issue at some point a set of Docker commands. We're just driving a set of command line utilities to get that application sent up to the image, installed, configured, and deployed. And in a few seconds or a minute, what we'll see is that the browser will launch again with our same application, this time running on Ubuntu Linux in a Docker container on Azure. Part of what's happening here is we're also trying to improve the experience and do a better job of having the rich Visual Studio experience drive a set of artifacts that can be used and shared across your engineering team. So rather than everybody having to know what values to plug into that publish wizard, we're starting to drop artifacts, like in this case a Docker file, that you can check into version control, you can share across the team, so now everybody comes in and they use the exact same settings. If you need to do a more advanced configuration, just go edit the file. It's not a big deal. That's what we will run next time we come through and the next time the tools work. So in a little bit, this will actually launch. There it is. And there we have our ASP.NET 5 application running in our Linux container in Azure. So ASP.NET 5 now running in Linux. Okay. You guys are just not thinking that's cool. No. Okay, let's spend a few seconds and quickly talk about .NET Core. We've talked about this a bit. Thinking about modern design, modern application patterns, more modular, package-based, cross-platform, and open source, all developed in the open. One of the things I want to talk about just for a couple seconds is sort of this open source aspect and open development aspect. I mentioned it's not just about where the code lives. It's not just about the fact that there are now more engineers able to work on and contribute to .NET and the .NET platform. Roughly 10% of the commits that we take across these repos, so the changes that are accepted, are being contributed by engineers that don't work at Microsoft. Regardless of whether you're a Microsoft engineer or not, that code goes through the exact same review process. When we push out specific versions, it goes through the same compliance and other kinds of checking. So everything is going through the same process. Actually, it's going through even more because we have even more people reviewing everything now, not only inside of Microsoft, but externally as well. If you go out to the repos, look at pull requests, look at the discussions that happen, you see just as much interaction and just as much feedback coming from non-Microsoft engineers as you do Microsoft engineers in many cases. An interesting aspect, a thing that happened recently, and it's over here on the right, it's very hard to see, but I think it's an example of the kinds of changes that have been happening in our industry. So this, oops, go back. This over here is a merge request. I just did it again. From the Linux kernel. And it references the .NET Core Runtime project, the cross-platform repo, as one of the justifications for that change going into the Linux kernel. So Linux making changes to make .NET better. Yeah, when I saw this 3 weeks ago, I think I also saw a pig fly by my window. But it's just awesome. It's just cool to see where we're getting to as a software industry and the level of collaboration that is really starting to happen now to make just all of us have better opportunities and better set up for success. So let's do one more quick thing here. Let me show you what this experience looks like for a developer on a Mac. So I've already gone and installed .NET Core and ASP.NET 5. And now I have a set of commands available to me. I can do a list and see what versions of .NET I have. And you see in this case I have 3 different versions of the .NET Runtime, or Mono in some cases, and ASP.NET 5. So this is just showing a little bit of the side-by-side. And right now, Beta 8 on the Core CLR is my default one. Now, I don't have Visual Studio. I don't have anything like that. So if I want to create an application, I'm probably going to go into a scaffolding tool like Yeoman. So I'm going to say yo ASP.NET to bring up an ASP.NET generator for Yeoman. And since we're running low on time, we'll just create a basic web application. We'll give it a name, call it VS Live Demo. And now we've got that created. So if I go in here and say cd VS Live Demo, and I look at that, you see that we've basically scaffolded out the same kinds of things that we would have gotten from a file new project in Visual Studio. So we have a set of controllers and views and project.json and so forth. Now, because I'm doing this all from the command line, I'm in total control. I need to go drive this experience. First thing I'm going to do is restore the packages. So we'll just do a DNU restore, which is going to go through and make sure I have the right versions of all the packages described in project.json. Now, we didn't do this in Visual Studio because Visual Studio understands this flow, right? So when you created the project, it issued that command on your behalf because it knew it was the next thing you needed to do. At this point, if we want to go kind of get it started, we can say DNX Web. And this will launch a lightweight cross-platform ASP.NET host that we call Kestrel here on my machine. Now that that's up, I'll switch back over here to a browser, and we'll go localhost, oops, and the browser, the host died. Well, but not soon enough for this to work. So you see that we're now serving up our ASP.NET 5 application here locally on the Mac. And because we have that in-memory compilation, I can go change code, right? Just come back and refresh the browser, and it'll pick up and recompile it. Of course, if I want a richer experience, I could use whatever editor I want. In my case, I can come in here and open this up in, just point to that folder, open it up inside of Visual Studio Code, which you can hardly see. But you get the idea. So now we got the same kind of rich experience. If I go into the controllers, open up the home controller, there's my code, right, that I can go in and I can do my development here, save it, refresh in the browser, and so forth, and get that iterative loop. Sharing this across folks that are using Visual Studio or not Visual Studio. So these things all kind of can stay in sync and more seamlessly work together across one set of environments or one set of projects. That's a really quick view at it. You can clap if you like it. But again, the thing to take away here is that what we're focused on is ensuring that we're creating and innovating and making the investments that you need to continue maintaining, enhancing, evolving your existing .NET projects, giving you what you need for your next project. So the .NET is the default answer for you for what technology you want to use for the next project, whether it's on Windows or not. Extending your .NET and ASP.NET skills into these new environments, these new demands, these new types of applications. At the same time, also opening up .NET, opening up ASP.NET, opening up the languages in a way that we can start attracting new developers into this ecosystem. I love all of my .NET customers, but I want more. I want a bigger ecosystem. I want more people actively working and actively involved in the .NET space, so that just makes us all more productive, gives us all more resources to leverage and work with. With that, I appreciate your time this morning. I hope this was useful. I hope you got some insights into what we're working on and maybe helped you decide where you want to spend the rest of your time this week. You got a great set of sessions, a great set of speakers. So take advantage of it, enjoy your time, and go build some awesome .NET apps. Thanks.